Question 11 is a page of lovely fast algebra and it's worth 8 marks. You should see this in an exam and think, yes, 8 marks. Okay, so expand the bracket. 3 times x is 3x. 3 times positive 2 is positive 6. And it's a 2-mark question. You get 1 mark for correctly expanding the x's, 2nd mark for correctly getting the product of 6. Part B is asking you to factorise completely. The fact that it's asking for you to factorise means they want you to remove the common factors, and the fact that they're saying completely means they want you to remove the highest common factor. So in order to do this, first thing I'm going to do is look at my numbers, and I'm going to decide what's the highest number that goes into 12 and 18, and the highest number that goes into 12 and 18 is 6. Then I'm looking at my letters. I've got x cubed and I've got an x. So I know there's an x in both. And because that's to the power of 3, but that is only 1 on its own, I can only take 1 as my highest common factor. And yes, I have a y in both. There's no powers on that y and there's 2 on there. So I'm limited by the fact that there's only 1 there. So my highest common factor is 6xy. Now I put my brackets in and I decide how I'm going to multiply that in order to get back to my original. Numbers first. 6 times what is going to give me 12? Well, that's 2. X times what is going to give me x cubed? Well, that's x squared. And y times what is going to give me y? Well, it would be 1, and we don't put a 1 there, so it's 2x squared. Subtract. 6 times what is 18? Well, 6 times 3 is 18. X times what is x? It would be 1, so we leave it. And y times what is y squared? Well, it's y. So that's factorised completely for 2 marks. Now, the fact that it's worth 2 marks is because 1 mark is for you factorising it correctly, but not using the highest common factors. So maybe you just put the factor of 6 on the outside, for example, because you're not confident with the letters. You would still score a mark for that, so definitely have a go. Part C, expand and simplify double brackets. In order to do this, I'm going to zoom in actually to see if it stops blurring. So first thing I do is 2x times x, and that gives me 2x squared. Then I've got 2x times by positive 4. It's going to give me positive 8x. Then I've got negative 3 times by x is negative 3x. Then I've got negative 3 times positive 4, which is negative 12. Then I'm going to collect and simplify. That's a positive 8x, that's a negative 3x. So they're going to go together to give me a positive 5x. I've done nothing with that 2x squared, and I've done nothing with that negative 12. And the final answer is 2x squared plus 5x minus 12. 2-mark question. Obviously you get an A1 for getting the actual answer completely correct. But you also get an M1 if you've managed to get 3 of the terms correct. So when you've expanded, you've managed to get 3 of those 4 terms correct. Part D is asking you to simplify for 2 marks, and what you need to do here is actually carry out the multiplication, but being aware of index laws as you go through. So again, deal with the numbers first, then the letters. The first thing I come across is a 5 and a 2, and 5 times 2 is 10. Then I've got an x to the power of 4 times by x to the power of 3. When you multiply, you end up adding the indices. So that's going to give me x to the power of 7. And I've got y to the 3 times by y to the 2. So that's y to the 5. So the answer there is 10x to the power of 7, y to the power of 5. Now, because this is an index law question, you actually get 2 marks for showing that you know the knowledge to get that right. If you haven't got exactly that answer, then you can get a B1 mark for just showing one of the index laws. So for example, maybe getting the x to the power of 7 correct, or for getting the y to the power of 5 correct. Question 12 again is all about knowledge and facts. There's nothing to work out here. Write down the value of 7 to the power of 0. Well, anything to the power of 0 is 1. Write down the value of 5 to the power of negative 1. Well, in this case, my first point of interest is to get rid of the negative indice. In order to do that, I put 1 over, and then whatever I'm left with, in this case, 5 to the power of 1 it would be, but anything to the power of 1 is just itself, so that's 1 over 5. And for this, I've got 9 to the power of a half, and anything to the power of a half is the square root of the number. So we actually end up with the square root of 9, and that actually gives us a value of 3. A little trick to help remember what to do with 9, or well, a number to the power of a fractional indice. And well, you know how it's really cool, like on the street, I'm not sure what street, just the street that you hear of all the time, to say like brap, 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 brap. Well, I use that to remember what to do, because with indices, you've got your base, your root, and your power. So whatever your base number is, you write it down. Then whatever the bottom of your fraction is, you write that as a power, as the root. And then whatever your top number is, your numerator, that's your power. And that's how I remember, if I can't remember the fact that the power of a half is the same as the square root. So remember, BRAP. 13a is quite straightforward, and again it's a B1 mark because it's a recall of information really. Write down the equation of a straight line that is parallel to y equals 5x plus 6. Now, in order to do this, you need to know that any linear equation in the form of y equals mx plus c, then y and x are the values of your y and x coordinates. M is the gradient, and c is the y-axis intercept. So the fact that they're asking you to write down an equation that is parallel, that means that it has to have the same gradient. And as we can see, the gradient is actually 5. So I need any equation that has a 5x in it. So I'm going to go for y equals 5x, add, and I can have any number here. I'm just going to go for 2. Question B is a tricky one, and you'll find that when I work this out, I'm going to be working in decimals. If you've worked in fractions, that's fine. Just make sure you check with the mark scheme or ask one of the teachers whether or not you've actually done it correctly. Okay, so there's a lot involved in this question. We need to find an equation of a line that is perpendicular to the line y equals 5x plus 6 and passes through the point -2, 5. So I'm going to be looking for a line that's perpendicular, and perpendicular means that they intercept at 90 degrees. So it's a right angle interception. So we're looking for a line that's perpendicular to that. Now, if you've got a perpendicular line, the major effect that that's going to have is on your gradient. Now, you may be thinking, oh, well, if 5x is the gradient of a positive line that's going up that way, if I'm doing a perpendicular line, something that crosses at 90 degrees, then it makes sense that if that's positive 5x, this would be negative 5x. But that's not correct. That's not how it works. if you're ever asked to find the perpendicular to a gradient, it's actually -1 over the coefficient of x. Okay, so I'm actually looking for a line with that gradient. Now, in order to give someone an equation of the line, I need to have it in the form of y equals mx plus c. And like we said above, m is the gradient, x and y are the values of x and y, and c is the y-intercept. Now they've given me, up here, they've given me the values of x and y, because that's what a coordinate is. A coordinate is a statement of x and y. So they're telling me that x is equal to -2 and y is equal to 5. So if I know that my original line had the gradient of 5x, I'm actually looking for a line where y equals -1 over 5x plus c. And in order to write that as an equation, I need to find a way of getting a value for c, because I need to know where my line crosses the y-axis. So in order to do that, I'm going to need to substitute in my values of x and y. Now, I know that y is equal to 5, so there's 5, and that equals -1/5 times by -2, and then I'm going to be adding whatever c is on the end. So let's work out what's going on over here. That is 5, and 5 is equal to... Alright, well first of all I've got a negative and a negative, so I know that my answer is going to be a positive. I do not need to write a positive, but I'm going to just to remind myself and you later on. So I'm going to have a positive product. Now, 1/5 times by 2. That's the same as 1/5 of 2. You can picture it as £2 being shared between 5 people. However you get there, you need to know that it's 0.4. Or if you're pretending it's money, then it's 40 pence, 0.40. But that's 0.4. And again, I'm going to have to find out what c is. Now, I solve to find c, so I need to get rid of that 0.4. So I subtract it away on both sides. So it cancels out there, leaving me with just c. And c is equal to 5 take away 0.4, which is 4.6. Or you may think of it as £5 take away 40 pence is £4.60. So now I know that c is 4.6. I can write my equation in the form of y equals mx plus c, because y equals the gradient, which is -1/5 of x, plus my value for c, which is 4.6. Again, if you've got the fractional answer, then check the mark scheme. In regards to mark allocation for this question, you get 1 mark for acknowledging the fact that the gradient of your new line is going to be -1 over 5. So you get 1 mark for showing -1 over 5. Now your second mark comes here from substituting the values in, and then you get your final answer mark for getting the equation of the line correct. Question 14 wants you to simplify this quadratic fraction fully. I love these questions. If you do not know how to factorize a quadratic 3-part expression, then you need to go and look that up, because we're not actually going to learn it here. Now, in order to simplify these, you have to factorize, and I'm going to factorize the top, and I'm going to factorize the bottom, and hopefully I'm going to come out with at least one of the brackets on top and the bottom the same, so I can cancel them down. So let's think. How can I put that into double brackets? X squared minus 2x minus 15. Well, it starts with an x squared, so I know my brackets need to start with x and x. Now, both my signs are negative, but this is the most important one to me at the start, remember? And the fact that that's a negative product means one of my brackets is positive, one of them is negative. Now, the fact that the middle numbers are negative means that the largest of my factor pair is going to be negative. So what numbers multiply together to give me 15 and have a difference of 2? Well, it's 3 and 5. And now to decide which is the biggest number, well, it's the 5. So the negative is the 5 and the positive is the 3. So that's factorised completely. It does not matter if you have x minus 5, x plus 3, as long as the positive is with the 3 and the negative is with the 5. Now I'm going to factorise the bottom. It starts again with x squared, so I've got x and x. This time I want two numbers that times together to give me negative 21. I know one's going to be positive and one's going to be negative. But they've got to have a difference of 4, with the biggest number being a negative in order to get a negative difference. So when I see 21, first thing that springs to mind is 3 and 7, and they just happen to have a difference of 4. So the largest number has to be the negative, and the 3 gets to be the positive. Now, as I'd hoped, I can see that that bracket and that bracket cancel out, and that's just going to leave me with my x minus 5 over my x minus 7. Now, you should always attempt these questions, and the reason you should always attempt these questions is because they're really generous on the marking. You get 1 whole mark for attempting to factorise the numerator of this fraction. So even just attempting to put it into double brackets is going to give you 1 mark. If you can only identify the fact that it's going to be 3 times 5 and you don't know what to do with the signs, then just put 1 as positive, put 1 as negative, because in order to get the 1 mark, you do not even need to have the correct signs in. So you get 1 mark for that. You need to get 1 mark then for factorising the denominator, and you get your A mark for getting the answer right. Now, in order to pick up the method marks up here, you have to have at least one of the brackets correct, okay? But it's always worth attempting.